We are going to look at 13 physics 3.4 out of 4 areas. Of course, this is the first unit, 3.4. Now, under 3.4, there are 4 main areas: center of mass, circular motion. There are 3 areas under that: rotational motion and simple harmonic motion. So these are the major areas that we will be looking at. Now let's go to the center of mass. I simply call it COM. It is where the total mass of a system of different masses acting. So that is the simple meaning. We just take some examples and look at this. Now if you look at motion of a high jumper, there is one special point that moves in a parabolic path. That means the person is jumping, even though it is a bigger mass, there is one point on the body where the total mass is acting, and that point, that is the center of mass, is moving in a parabolic path. That is a very simple idea. Take another example. Now think of your dining table. If you are ready for dinner, look at the items. Now you have many items, the pots, the plates and glasses and all that. So they have their own masses. Okay. Now when you look at all these masses, there is one point on the table where all these masses together acting, and that is called the center of mass. So the point where the total masses of a system is acting. So that is the center of mass in a simple meaning. So the definition: the point where the total mass of different particles of a system is concentrated or acted is known as the center of mass. So that is the main idea of the center of mass. Now it is not a very complicated idea. It's a very simple idea. You can understand that very easily. Okay, now there is a simple rule. What is that rule? We are going to look at 2 masses and the center of mass of these 2 masses. Okay, example, seesaw. So we had 2 masses here at the end, that is M1 here and M2 there. M1 and M2, sorry, that point should be here. I don't know how it came there. So that is your M1. I just shifted, we just correct it. Now 2 masses at the end of the seesaw, and we have the distances. R1 from M1 to the center of mass, that is the COM. So this distance is R1, and from the other mass M2, that distance is R2. So you have M1 and M2 masses, and you have R1 and R2, the distances from 2 masses to the center of mass. So what is the rule? This is a very simple rule. M1R1 equals M2R2. That means the product of mass and the distance equals other mass and the other distance. So very simple idea. You can rearrange this if you want. M1 over M2, bring it here, equals R2 over R1 down here. So that is not a very difficult formula to remember. You can remember that M1R1 equals M2R2, and then you can use this for problem solving. Okay, we have a question. There are 2 masses, 4 kilogram and 6 kilogram, are attached with a string of 40 centimeter. That means the 40 centimeter is the distance between the 2 masses. Calculate the distance of the COM from 4 kilogram mass. From the center of mass, what is the distance to the center of mass from the 4 kilogram mass? Always draw a diagram. If you want, you can just draw a simple diagram like that, and then you can put the masses, then you can mark the distances easily. Alright, applying the formula. Now M1 R1 equals M2 R2. Now we are assuming that M1 as 4 kilogram, M2 as 6 kilogram. So that these are the 2 masses, M1 and M2, 4 and 6. If R1, that is from M1, that is 4 kilogram, the distance is R1. So that is 4 kilogram. That distance is R1. That is 6 kilogram, and that distance is R2. But the total distance, remember, that is 40. Therefore, if one is R1 from here, other one should be 40 minus R1. So that is 40 minus R1 gives you that distance R2. So that is R2 is 40 minus R1. Substitute the values. So one is 4, R1, that distance 4 and R1. Other side 6. And then that one is 40 minus R1. When you simplify, you can get R1 equals 24 centimeter. And that is the bigger distance. But the R1 is from the smaller mass, 4 kilogram mass, right? 4 kilogram. M1, that is R1 is from that. You can see that's a bigger, smaller mass, bigger distance. Other side, 40 minus R1, that is 40 minus 24, that's 16. So that means from 6 kilogram mass, the distance is 16. So from here, it is 60. So that is 24. That one is 16. Now remember, don't use the scale of this diagram because that is the diagram coming from the theory. You need to draw your own diagram. Okay, so don't worry about that distances. So bigger mass mean smaller distance. What is the meaning of that? Center of mass is always closer to the bigger mass. Obvious thing. Center of mass is the place where all the masses are concentrated. Therefore, bigger masses are concentrating closer to the center of mass, or the center of mass is concentrated closer to the bigger masses. So that's a good example. Right, now we are going to look, and we were looking at two masses all this time. Now we look at a number of masses, more than two, like 3 and 4, 5 masses along a line. Now in this case, when we are looking at more masses, we have to have a special case. We are looking at what is called a reference point, and a line, okay, can be used. So reference point. Now what is the reference point here? Look at this diagram. We have two axes, that is y-axis, that is x-axis, this way. So we have the point where the two masses are, two axes are joining together. So that is the reference point where the two axes join. And then keep the masses like M1, M2, M3 and so on along this line, that is the x-axis. So we have the x-axis where the masses are placed. Then we have the reference point here where the two axes are meeting. Right, now, so we have M1, x1 is the distance from the reference point here. M2, x2 is the distance from the reference point here to that distance. If we have M3, the same thing, M4, and then we get the mass and the distance. Assuming for this situation, to make it simple, we use two masses, but you can have any number of masses. So if that is the reference point, M1 plus M2 should be the total mass at the reference, at the center of mass. So distance from the, again from the reference point to the center of mass, xc. All right. So we have that situation. It's a very clear diagram, very simple diagram. So the rule is, if you multiply the mass and the distance, m1 x1, that mass here, m1 and x1, then m2 x2, add. If you have m3 x3 plus m3 x3 and so on, keep adding. So all the masses along the line are multiplied with their distances, and then the sum, the add, equal total mass, that is where the center of mass is. That is the center of mass where all the masses are concentrated. So m1 plus m2 plus m3 and so on, times xc. So distance. So that we are basically saying we multiply the mass and the distance for each individual masses equal total mass times that distance, that is the center of mass, to the reference point here. Okay, so the very simple equation. Therefore the product and the sum here, and we have the center of mass and the sum of all the other masses. Therefore in this equation xc equals this side m1 x1 plus m2x2 divided by this. Okay, that is also very simple, isn't it? If you understand this diagram, you can just get this formula. It is not a standard formula, it's a general formula how you get xc for more than 2 masses for x. Even 2 masses we can do that, but many masses. Okay, that is the rule. Okay, going down, we have example. Point masses. We have 3 kilogram and 5 kilogram 2 masses. The distances from the reference point 4 meter and 8 meters. From the reference point, which is here, you can see the diagram here. That is the x-axis, that is the y-axis. They are meeting at the reference point. So we have first mass 3 kilogram, distance is 4 meter from the reference point. Second mass 5 kilogram, 8 meter from the reference point. If you have a third one here, and then you get that mass and that distance and so on. So we are going to find this one here, center of mass. What is the distance from here to here, xc? We just simply apply that formula. What is the formula? You don't have to remember. We understand the procedure method. Okay, what we do, m1x1 plus m2x2 plus and so on. So that is the product of masses and the distances equal the total mass times distance from the center of mass xc. So 3 plus 5, xc equals 3 plus 3 times 4, mass 3, and then that distance 4 plus 5 plus 5 kilogram plus 8 meter distance. If you have the third mass, you do the same thing. Simplify, that is 3 times 4, 5 times 8, that is 3 and 5, that is 8, x equals 12 plus 40. When you simplify, x equals that is 52 divided by 8, you get 6.5 meters. So that distance is 6.5 meter from the reference point. Okay, so you can see how we apply the method when we have many masses sitting on along a line, and we are using what is called the reference point method. Okay, all right, now we just stop here. That is a short video for you to look at. Then you can decide whether you like it or not. If you like it, you can just send me a message, and then you can get the full course. There are about 12 to 15 videos that is you can get from me. Okay, so thank you for listening.